Hello, working drawing students. Here's the video presentation that goes with lesson number 4 regarding manufactured features and surface finishes. There are 2 objective sheets in this lesson. The first one has to do with our features. So features, these are the objectives for features, and it is recall the description, purpose, and dimension requirements of the following common mechanical features. These are typical features that you would see on mechanical parts, namely a fillet, a round, what's a counterbore, a countersink, a spot face, a boss, a lug, a flange, chamfer, neck, keyway, and key seat. There's 2 different terms. We'll explain those later. What's a knurl, and also a bushing. Then the terms we're going to use is interior transition, exterior transition, recess, fastener, cap screw, flathead screw, protrusion, bearing surface, mounting hole, mounting fastener, groove key, power transfer, and shear members. So pay attention for those words in this presentation. Okay, so these would be your common manufactured features. Okay, you have a neck. All right, that's just like a little recess. It's hard to see right there, but we'll get it. And then this is a bushing here that fits on top. There's a flange. A knurled is a textured surface. Counterbore, a fillet versus a chamfer on the external surface. Here we have a spot face and a boss and what we call a lug here. Then this was from another textbook. It has a lot of the same features, but it's just labels them differently. Okay, so the first one is a fillet. That's a rounded interior transition. A fillet is a rounded interior transition. It's used to strengthen adjoining surfaces. The part's thicker with a larger radius there, and it'll be stronger. It allows for the part to be removed from the mold. If you were molding a part and you had a sharp corner there, it'd be hard to get the part out of the mold. You dimension it just like you dimension a radius, and it's usually on this internal transition. It's usually created by the corner of the cutting tool. So a cutting tool can have a corner radius machined into the cutting tool, and then that cutting tool then thereby generates that fillet feature. Rounds. A round is exterior transition between surfaces. Again, it's used to make edges easier, safer, and to handle. It improves the strength. It allows the part to be removed from a mold. You dimension it just like a radius, and it's usually created by the path that the cutting tool takes when that part's being machined. When it comes to dimensioning fillets and rounds, again, just like a radius. Now, if you have a part that has a lot of different fillets on there, and you had to dimension every one, you could get a really crowded drawing. Like, say, a casting or a cast part has a lot of fillets and rounds on them. So what you would do is use a note that said, unless otherwise specified, fillets are 6 and rounds are 3. Or all casting radii are 6 unless noted. So if you have a lot of fillets and rounds on your parts, it's good to do it with a note like this. Next feature I want to talk about is the counterbore. It's a cylindrical recess around a mounting hole. It's usually used to recess the head of a mounting fastener, like a cap screw. So you want the head of the screw to sit below flush. So you'll create this counterbore feature to keep that head of the cap screw sitting below flush. The dimensioning can include concentricity to the hole. Again, that could be GD&T, but we'll talk about that later. The basic dimensioning requirements for a counterbore are, first of all, what is the counterbore diameter? Well, excuse me. This diameter here is for the through hole, and typically you would see THRU here. So the diameter 375 is for the through hole. This here, this U-shaped symbol, that's the counterbore symbol. And it tells me that the counterbore has a diameter of 0.625, and you'll typically put your tolerance on that feature size here. And then here's our handy depth symbol and the depth 1/4 inch. Okay, so this is how we would dimension a counterbore. There would be other ways to do it, like for instance, you could dimension, instead of dimensioning the depth of the counterbore, you could dimension the resulting thickness of this hole here. That's just another way to do it. So that's all for counterbores. Another similar feature is called a spot face. Spot face is a shallow recess around a mounting hole. It's used to provide a good bearing surface for a mounting fastener. Let's say, for instance, that the surfaces in this picture here were cast surfaces. You would put the 375 through hole in there, but you would still have a hard time using this as a bolting location because you don't have a flat surface to bolt against. That's what the spot face does. It gives you a good bearing surface for your mounting fastener. And this is common when a mounting hole is machined into a cast surface, and it can be dimensioned by the depth or by the remaining material, like I just said. So in this case, what we've got is we've got the depth. I mean, typically this is how we dimension a spot face. When I talked about counterbores before, we typically dimension counterbores by the depth of the counterbore. Spot face is typically the thickness of the mounting area here is what you dimension on a spot face. Again, it's a shallow recess. And again, this diameter, the 625, this is a little bit different about a spot face. The 625 includes any corner radiuses you would have here. So the 625 is a guaranteed flat dimension around that hole. That's how a spot face is dimensioned. Okay, here's some examples of dimensioning with counterbores and spot faces with fillet radiuses. Okay, let's talk about this one. This is a counterbore hole with a fillet radius specified. Okay, so the diameter 0.5 millimeters through, that's the hole. Okay, again, we're dimensioning this hole diameter in the round view. We have a counterbore of a diameter 10 millimeters. It has a radius of 1. And that radius of 1 is the corner radius down on the bottom of this counterbore. And its depth is 0.25. And what we're showing here is different ways to dimension this, or what it means. I like using the symbols. This is how I want you to dimension counterbores if you have to use a radius. This one, it shows you what it means. I don't like this. It's 0.25. It should 0.25. And then, so this is just what it means. Okay, so this is a spot face here. When a fillet radius is specified for a spot face dimension, the fillet radius is added to the outside of the spot face diameter. Okay, so look at this. See this 10 millimeters here? It applies just to the flat surfaces, not to the radiuses. So the radius here is beyond the 10 millimeters. That's one of the differences between a counterbore and a spot face. Next is a countersink. A countersink is a conical recess around a mounting hole. It's usually used to recess the head of a mounting fastener, like a flat head screw. So what'll happen is the screw, once the screw seats in the hole, it sets below flush. That's typically what the head of the screw sits below flush. This could be used on a threaded hole for a screw lead-in, to just try to chamfer the top couple of holes. But in this case, what we're doing, this is a true blue countersink, and here is how we dimension a countersink. Well, first of all, this applies to something that has 6 holes in it. The diameter is 0.281 for the through hole. And here, this V symbol, that's the symbol for a countersink. So for a countersink, you use the symbol, you use the diameter. Now, the diameter specified for a countersink is the diameter across the top of of the countersink. So it's like the biggest diameter at the top surface where it breaks out into the part. That is this diameter here, and you always have to have an angle 100 degrees. If you don't have a block tolerance here, you need to put your tolerances on both the diameter and the angle if you don't have a block tolerance. I'm going to stop this movie right here, and we'll pick it up on the next one. Thank you.